Specimen assessment material for Unit 1 and question 10. We have got a guitar, and this is similar to this situation here where we've got a taut string, so it's attached at each end. The diagram shows the first mode or the first harmonic of the string. On the diagram, label a node and an antinode. So we have got our nodes at each end and antinodes in the middle. So pretty straightforward, 2 marks. State the relationship between the distance PQ and the wavelength. So this is actually half a wavelength, because that would be back to there again. So if one wavelength is one complete oscillation, so up and down and back to the start again, that would be one. So this is only half of our total. So PQ is half a wavelength. Draw the second mode of vibration, or the second harmonic. So if we did it faster and faster, what would we get in the next stationary wave? So if this one, a good way of doing this is this one's got 2 nodes and the next one would have an extra node on, so keep adding a node each time. So this would have another node in the middle, and so this would go up to the middle again, down to the middle again, and that would vibrate like that. So another pretty straightforward 1 mark. You've learnt all these diagrams. The next 3 marks are a little bit more tricky to get the right points across. So why stationary waves are seen only at certain frequencies. Well, this string or whatever will have a natural series of frequencies that produce these shapes. So the string has a natural series of frequencies, and these will match up to half a wavelength, 1 wavelength, 1.5 wavelengths. So that's the next thing we're going to mention. These correspond to a number of half wavelengths. So the ones that we've got here are, e.g., half a wavelength, 1 wavelength, 1.5 wavelengths, 2 wavelengths, and so on. And then we need a 3rd mark, saying that the wave is only really produced when the frequency of whatever's vibrating the string equals one of these wavelengths. So that's a tough point really to make. So a stationary wave is only produced when we're talking about frequencies here. When the frequency of vibration produces waves of these wavelengths. That really means if we vibrated it to get 3/4 of a wavelength, then that wouldn't work. So it's only when we vibrate it to get half a wavelength, 1, 1.5, 2, and so on, that you'll actually get these standing waves. So a little bit of a tricky end, but you should have certainly got 2, 3, 4 marks there as an absolute minimum.